All right, continuing on with our identities. We're looking at Pythagorean identities now. So where do they come from? First one. Here's our first Pythagorean identity. Sine squared plus cos squared equals 1. And really it's coming from our unit circle. We've got our radius of 1. Make any triangle. The unit circle is really all the infinite number of triangles all the way around. We got an x value, we got the y value. So the point of any of them is x comma y, and we've developed that to be cosine comma sine. And we know Pythagorean theorem says x squared plus y squared equals r squared. A squared plus b squared equals c squared. The x is cosine, and the y is sine, and the r is 1. Working through to prove these ones, we've got other identities there. And we can prove those just by changing everything to sine and cosine. We're going to be doing a lot of work through with them. I'm just going to do one of them. The process would be the same for the other one. I'll start with the first one here. So tan, that's the same as sine squared over cos squared plus 1. Well, we've got two fractions. Hey, that's like over 1. Let's get a common denominator. So sine squared theta plus something there. Well, this one we got to multiply by the common denominator. And so we got sine squared plus cos squared. Oh, hey, we just went through that on the other page there. That's 1. 1 over cos squared. 1 over cos squared. That is secant squared. Oh, look at that. Left side equals right side. We would do the same with the other theorem there, or the other identity. Okay, there's your list of your 3 Pythagorean identities. They could be switched up a little bit. Okay? Meaning we could rewrite them. So your first one, just rearrange them all the way through. You have to be able to identify. Time that you're going to use these, anytime you've got any squareds, look for one of these or rewriting them as an option. So now there's your bit.ly link to check it out, see which ones you can rewrite, which one is not equivalent to the others, or to that one right there. All right, let's start working through with these. Proving again. So we'll use our left side and right side. Hey, go to sine and cosine all the way through with these. Hey, cotangent. That's cosine over sine. Tangent. That's sine over cosine. Let's get a common denominator. So common denominator that we're going to have is sine cos. I need to multiply this fraction by cos over cos. I need to multiply this one by sine over sine. Yeah, I know it looks like garbage there. So we got cos times cos, that's cos squared. Plus sine times sine, that's sine squared. Hey, cos squared plus sine squared, that's equal to 1. Go whipping over to the right side now. Cosecant. Cosecant is 1 over sine. Secant is 1 over cos. Bring it into one fraction. 1 over sine theta cos theta. Oh, look at that. Left side equals right side. Okay. Let's check it out over here now. All right, this is going to be one of the few times where you don't need to change it to sines and cosines. We're going to actually use some factoring first. Although if you did go to sine cosine, you still would be able to prove it and it still would be correct. So let's do our two sides. I'm going to start on the right side with this one. I notice with this, they both have a cotangent in it. I'm going to factor that out. So cot theta, bracket. I'm left with cosecant squared theta minus 1. Oh, I look at my formula sheet, and cosecant squared minus 1, hey, that's cotangent. So cotangent theta times cotangent squared theta. Multiply those two together. That gives me cotangent cubed theta. Oh, left side equals right side. We're done. So here's some more hints on what to be working with. Again, common denominator we got to be able to use. Difference of squares, factoring. We have to always look for factoring. Either as factoring out a GCF, factoring difference of squares, any types of factoring. We also got to be able to rationalize a binomial. So looking at these, this will happen every now and then. They're more complicated types of questions, so. In order to do that, we multiply the numerator and the denominator by the conjugate, which is the exact same as the denominator, opposite sign in the middle. So we're taking the numerator and the denominator, multiplying it by the same terms as the denominator, opposite sign in the middle. At that point, we're expanding in there. You can take this on the side if you'd like and expand that. Unless you remember the shortcut of it. But I would just say take it on the side, expand it. Okay. Where you're going to see this kind of a strategy, this kind of an idea, is when you've got one plus sign or minus, or one plus or minus cos. All right, example 2 now. And we notice, ooh, look at that, there and there. Those are conjugates of each other. So as soon as you see things that have conjugates, same terms, opposite signs in between, that's going to be the indication to do what we just talked about. So let's start. It really doesn't matter which side you start on. They're both very similar. So I'm just going to start on the right side. And we're going to take it and multiply by the conjugate of the denominator. This here is a form of 1. That's why we can do this. It's something over itself. We're really multiplying by 1, just changing the way it looks. So then we get sine theta times 1 minus cos theta over. And we've got, I'll bring it on the side over here just for now. Let's distribute that together, expand it. 1 times 1 minus cos theta plus cos theta minus cos squared theta. Those cancel off. 1 minus cos squared theta. Or we can remember that there's a little trick. Whenever we multiply conjugates, it's always going to be the first term squared, always minus the second term squared. So first term squared, always minus second term squared, every time. Let's bring that back in. 1 minus cos squared theta. And then we notice, oh, hey, 1 minus cos squared theta, we've got a squared there. Pythagorean identity is going to be somewhere in there. And that's going to be, oh yeah, sine squared theta. Oh, look at this. We've got a sine squared, or sine up there, and a sine squared. So we'll take one of them away from there. 1 minus cos theta over sine theta. Oh, right on, the left side equals right side. We are done. All right, and the next one. Now this one I also have conjugate pairs, but they're on the same side. So I don't have to do that multiplied by the conjugates. That's just when they're on opposite sides of the equal sign. Well, got two fractions. Let's take it into a common denominator. So multiply the first one by 1 plus cos theta. Multiply the second one by 1 minus cos theta. And we get common denominator of 1 minus cos theta, 1 plus cos theta. And this was 1 plus cos theta when we multiplied that in there, plus 1 minus cos theta. Well, hey, that denominator, those are conjugate pairs. We know what that's going to turn into. Square the first one, minus, always minus, square the second one. Numerator, we got 1 plus 1, hey, that's 2. Cos plus a negative cos, hey, those cancel off, they're gone. Now we go back to 1 minus cos squared, hey, that's sine squared. We've got 2 over sine squared theta. Hey, let's go to the right side now. Cosecant, that is 1 over sine squared theta. Oh, multiplied by 2, that's 2 over sine squared theta. Left side equals right side. Boom. And now we're coming back to solving. Not proving, but we're solving. We're going to use some of the techniques that we just learned in the proving and apply them into here. This looks very similar to what we've done before, except one big thing. We got cosine, we got sine. We need to have the same ratio there, same trig, to be able to solve it, to be able to factor. So we say, I got to either turn this one into sine, or I got to turn this one into cosine. Well, there's nothing on my formula sheet, no identities that allow me to turn sine into cosine. This is also a Pythagorean identity lesson. So therefore, we're going to look at the squared. The one that's the squared is the one that we change. And I know that sine squared plus cos squared is 1. So then sine squared theta equals 1 minus cos squared theta. I'm going to substitute that in. So 3 minus 3 cos x minus 2, 1 minus cos squared x equals 0. Let's distribute that in. 3 minus 3 cos x minus 2 plus 2 cos squared x equals 0. And let's simplify that. Put it in order. So 2 cos squared x. And then minus 3 cos x plus 1 equals 0. And we factor it. And factoring gives us this. And then same as we've done all the way along. Cos x equals 1/2, or cos x equals 1. Go to our unit circle, our reference angles, whatever we need. Let's look at what our domain is. We need to be in radians now, and we're going from 0 to 3 pi over 2. That's as far as we get to go. First one. Cos is positive here and here, but we got the no-go on quadrant 4. So we've only got a quadrant 1 answer. That one turns out to be pi over 3. And then we've got the one where cos is equal to 1. And that's here at red at 0. It would also be at 2 pi, but we're not allowed to go that far. So there's your two answers. That's it. Bring them together is equal to 0 and pi over 3. Woo! We are done. And there's your two discussed questions. And we will see ya.